All right, here are solutions to our 8th and final written problem for Math 243, Spring 2020. The idea here, let's see, we're dealing with proportions, two different proportions. I suspect that the probability that someone in Oregon is a rock climber is different than, I think that'll get repeated later on, but that'll be important, the probability that someone in California is a rock climber. To test my claim, I randomly select 200 people in Oregon. So if I want to make my Oregons my ones, then this would be N1 right here. And 300 people in California. By default, those must be my 2s, so that would be N2, the sample size of California. And I find that 18% of the Oregon sample rock climbs. So this is a little bit tricky, I guess. What I'm really telling you here is P hat for the first group is 0.18. But that's not what you need. You need to know X for the first group. Well, X is the number that rock climb. 18% of 200 rock climb. If you take 0.18 and multiply it by 200, you could figure out that that means that 36 of them rock climb. So from this information, we can figure out that X1 is 36. Similarly, since 15% of Californians, or the Californian sample rock climbs, that tells us that P hat, the sample proportion for the second group, is equal to 0.15. But that's not what we want. We want X for the second group. Well, that's 0.15 times our sample size, 15% of 300. So 0.15 times 300, that ends up giving me 45. That's my value of X2. Anyways, can I conclude with 95% certainty? This is telling us that alpha is equal to 5%, that the proportion of all people who rock climb in these states differ. So again, two-tailed test. State the null and alternative hypotheses. Sure. Null hypothesis and alternative hypothesis, same symbols we've been using. What we want to do when you have a two-proportion z-test is you want to compare together the population proportions of the two groups. So maybe P of Oregon and P of California. P of Oregon and P of California. My null hypothesis would be that those two things are equal. And my alternative hypothesis, it could be a less than, a greater than, or a does not equal sign, because I put differs here. Say does not equal sign. This is a two-tailed test. And then B says to sketch the appropriate picture, don't bother with shape, center, and spread. All right, so here's my picture. I'll draw something that's approximately normal. And then I'll put 0 in the middle because this is hypothesis testing. Then to get all the other numbers, I need to go to my calculator. Hit stat and then tests. And go down to 2-prop, z-test. 2-prop because there's two proportions. Z because proportions are always Z. And then test because it's hypothesis testing. Ask me for X1, N1, X2, and N2. Well, hopefully I have those all written up here. X1 is 36. N1 is 200. There's 36 of the 200 Oregonians. I'm making my ones the Oregonians. X2 is 45. And N2 is 300. 45 of the 300 Californians. And then I want to have does not equals in here. So I'll go down. I can either calculate or draw, but since it's p-value, I've been doing draw, so I'll leave it like that. And so what we're looking for is a test statistic and a p-value. The test statistic is 0.8919. You can indicate that with the letter Z. And since it's a two-tailed test, I want to shade to the right of that value and to the left of the negative of that value, negative 0.8919. And just so the reader doesn't get confused, I won't label that one with a Z so the reader can tell what my test statistic is. The total shaded in area is what's called my p-value. So in this case, the p-value, pretty big, 37.24%. And that's my picture. And for part C, it says state your conclusion. Man, I'm really getting lazy. All 3 parts, hopefully at this point in the class you know what I mean by all 3 parts. I want you to tell me why you're doing what you're doing, because the p-value is greater than alpha. What that means for the null hypothesis. Well, anytime your p-value is greater than alpha, that means you cannot reject your null hypothesis. And if you can't reject your null hypothesis, you can't say that your claim is true. So I cannot conclude that the proportions of people that rock climb in these states differ. And that's what we're looking for when we do hypothesis testing with two proportions. And as you see in part 2 here, you can also do confidence intervals with 2 proportions. So we're going to use the same data as above, I suppose that's supposed to say. And we're going to create a 90% confidence interval for the difference in the proportions of people who rock climb in Oregon versus California. So since it says Oregon versus California, it would make the most sense to make Oregon's my ones and Californians my twos. Turns out you can do it either way. It's just harder to interpret the negatives and the positives if you do it the other way around. So I'm going to leave Oregon's as my one and California's as my two, which is what I did the first time around. So I'll go to test, and then instead of grabbing 2 prop z test, I'll grab 2 prop z interval. And my x and n values are already in here. How convenient. My confidence level, what did I say? To make a 90% confidence interval? Sure. And then I'll go down here and calculate. And these values, oh good, I got a negative value. I was kind of hoping that would happen. Sure. What I'm supposed to do is first sketch the picture. So when I sketch my picture, I want to make sure I include 3 things. The level of confidence, 90% in this case. The bounds of the interval, which are given to me in the output here conveniently. So I got negative 0.0261 and positive 0.0861 if I want to round to 4 decimal places. Not super important that you do. And then I also like it if you include the point estimate in here. Let's see if I explicitly asked you to do that. Yeah, I did. Level of confidence, point estimate, and the bounds of the interval. The way you can get the point estimate is, well, you can add these up and divide by 2 because the point estimate's always halfway in between your 2 bounds. Or you can just take the difference in the 2 p-hats. So 18% minus 15% is 3%. 0.03 would be what goes there. That's everything I need for my picture. Now I can interpret my answer. Essentially what I'm saying is if I take the proportion of all people who rock climb in Oregon and subtract the proportion of all people who rock climb in California, I'm going to get some number. And I don't know what that number is because I'd be subtracting population proportions, and I don't know population proportions. But based just on my sample proportions, I am 90% sure that that number falls in between these 2 numbers. In other words, that between 2.61 less percent and 8.61 more percent of people rock climb in Oregon than California. Maybe I'll try to write that over here in red. So there we go. There's kind of one way that you could write your conclusion. The key things to hit on here is understanding that because Oregon was my ones, these are all relative to my Oregonians. So this negative means less Oregonians. This positive means more Oregonians. And we're talking about population proportions here. So not just in my samples, but of everybody in these populations. So this is the conclusion that I got. And I suppose that ends this written problem.